In this example, I'm going to sketch the graph of the polynomial function negative 2x cubed plus 6x squared by first finding the polynomial's in behavior, its x-intercept, and its x-intercepts, and its y-intercept. So first of all, in behavior is determined by the degree of the polynomial and the leading coefficient. And more specifically, it's determined by whether the degree of the polynomial is even or odd. So first of all, this polynomial has degree 3. Degree is the highest power of x in this expression. The leading coefficient I'm going to abbreviate. Leading coefficient is negative 2. So the important thing about the degree here is the fact that it's odd. The important thing about the leading coefficient is that it's negative. And so for end behavior, when a polynomial has odd degree, that means that the two ends of the graph are going to be opposites. One end up, one end down. For degree 3, think of the graph of y equals x cubed. It looks like this. Now, when you have something more than just y equals x cubed, you're going to have more twists and turns in the middle. So we erase the middle part here. So if it were just positive y equals x cubed, the end behavior would look like this. The fact that it's a negative leading coefficient means actually I want to reverse this. The negative number would reflect it across the x-axis. So we end up with end behavior where it's up on the left and down on the right. There's a chart in the notes for this section that I posted that shows you, okay, when the degree is odd, leading coefficient is negative, end behavior looks like this. But I wanted to talk through the way to reason it. So picture y equals x cubed. So end behavior would be like this. I don't know how to show that to you guys, but so like this, the end behavior. But when you multiply by a negative out front, that's going to flip it. So now the end behavior is like this. So up on the left, down on the right. Okay. Now, x-intercepts. So to find the intercepts, we need to focus on the zeros of the polynomial. So to find the zeros of a polynomial, you just take this expression and set it equal to 0. So negative 2x cubed plus 6x squared, set that equal to 0. Well, if I'm solving this polynomial equation, I would factor out, we've got common factors to pull out here. Say we factor out negative 2x squared. Then what's left would be x to the first, from the first part of this expression. If I factor out a negative, then that's going to leave a negative behind. Negative 3, in fact. Here, and notice, if I distribute, just to double check what I did here, negative 2x squared times x will give me negative 2x cubed. And then negative 2x squared times negative 3 will give me positive 6x squared there. Set that equal to 0. Set each factor equal to 0. From here, we end up with x equals 3 or x equals 0. And actually, let me write out where that came from. So I don't want to take too many liberties here. So if we set the factor negative 2x squared equal to 0, divide both sides by negative 2, then we have x squared equals 0, which means x equals 0. If x minus 3 equals 0, add 3 to both sides, x equals 3. So the x-intercepts, or the zeros of the polynomial, are 0 and 3. Now the other thing we need to note about these x-intercepts, I'm going to write them down up here, are their multiplicities. So the fact that this factor, so x equals 0, came from an x squared, so an x to an even power, means that this 0, at 0, has even multiplicity. Has multiplicity 2. And x minus 3 came from this factor, x minus 3 to the first. So the multiplicity of this 0 is 1. So we want to note that 3 has odd multiplicity. The multiplicity determines whether the graph goes through the x-axis or does it just touch the x-axis and turn around. so if you have this written down, I'm going to erase the work that I showed here in finding the intercepts. The important outcome here is that we have a 0 at 0 with multiplicity 2, and a 0 at 3 with multiplicity 1. Okay, last fact I want to get written down before I draw this graph is the y-intercept. And we find the y-intercept by plugging in 0 to this function up here. So that'll be negative 2 times 0 squared, cubed, whoops, negative 2 times 0 cubed plus 6 times 0 squared. Well, that's just going to be 0 plus 0. So y-intercept is 0. Okay, so now we want to collect this information and sketch the graph. Okay, so when you're sketching the graph, my suggestion is to follow these steps. So first, plot those x-intercepts. So this graph has x-intercepts at 0 and at 3. Once you have the x-intercepts plotted, then draw the ends of the graph using end behavior. So what I mean by that, okay, so the graph goes up on the left. So take your intercept farthest to the left, have the graph go up from there. And then it goes down on the right. So take your intercept that's farthest to the right, have the graph go down from there. So that's filling in the end behavior. Lastly, use multiplicity to fill in that middle section of the graph. So down here, use the multiplicities of those zeros to fill in the middle section. So what I mean there is, so we would say, okay, I've got this x-intercept at 0. 0 has even multiplicity, which means the graph will touch the x-axis and turn around. So the graph at 0 is going to just touch the x-axis and turn around, so it's going to go back up. At some point, your graph is going to have to turn back around and touch this next x-intercept. And by the way, so just using what we know in college algebra, we can't determine this high point. So you may have your graph go way up high and come back down, or someone else might draw their graph just going a little bit above the x-axis and coming back down. That's fine either way for our purposes in this class. We can't determine this highest point. If you take Calculus 1, you will be able to determine this highest point. But for now, the important thing is that you have the correct end behavior and you have the correct behavior at your intercepts. So at 0, the graph should touch and turn around. At 3, this has odd multiplicity, which means the graph goes through the x-axis. So at 3, your graph should go right through the x-axis, which is nice because that agrees with our end behavior. And so this right here would be the sketch we've generated using end behavior, x-intercepts. We didn't actually use the y-intercept, but the y-intercept, notice it does match what we came up with at 0 to get an overall idea of what the graph of this polynomial looks like.